Hello, this is Reading Rails, and I'm Mike Verrata Stone. And today I think I'm going to continue exploring hashes like we did last week, the core extensions to hash. And we left off with deep merge. So let's take a look at the next one, which is accept. So accept is a nice and small one. Let's just see what the documentation reads. So returns a hash that includes everything but the given keys. So if we have a hash of A true, B false, C nil, hash.accept C is going to be everything except the given keys. So that makes sense. This is useful for limiting a set of parameters to everything but a few known toggles. So person.update params person except admin. And accept is just going to dupe it and then call accept bang. And as is the common pattern in Ruby, the bang is going to be different from the non-bang version in that it will actually modify this object. So it just goes through each key and deletes that key, then returns itself. So that's pretty straightforward. I don't think we really need to explore that anymore, so let's just look at the next one. Indifferent access. Okay. So require active support hash with indifferent access, and then returns an active support hash with indifferent access out of its receiver. So we get a hash with indifferent access. A is going to be 1. Okay. New hash from copying default self. Alias nested under indifferent access with indifferent access. Called when object is nested under an object that receives with indifferent access. This method will be called on the current object by the enclosing object and is alias to with indifferent access by default. Subclasses of hash may overwrite this method to return self if converting to an active support hash with indifferent access would not be desirable. Okay. So new from hash copying default self. So I'm just going to see what this is all about because I have no idea. I kind of have an idea of what hash with indifferent access is. I'm a little familiar with that. As you can see in the document here, it's a symbol. A is the key, whereas with indifferent access, it's going to be a string. But let's go ahead and see what this method does. So dig a little deeper. So active support hash with indifferent access. Find that hash with indifferent access, and we want to take a look at new from hash copying default. Okay, so hash with indifferent access dot new from hash copying default given a hash. So hash equals hash dot to hash. I suppose that's just to guard that this is actually a hash. In our case, we know we have a hash because we're coming directly from the hash class. So new hash dot tap, do new hash, and then new hash dot default equals hash dot default. Okay. Okay, so I'm going to explore the Ruby documentation. And let's take a look at default. Returns the default value, the value that would be returned by hash if key did not exist in hash. See also hash new hash default. Okay. So the first thing that I see here is that it looks like if the default is a block, was implemented via a block, then this method won't. Oh no, never mind. I did not look far enough. So default proc. There it is. Okay. If hash new was invoked with a block, return that block. Otherwise, return nil. Okay. So, well, that's pretty cool. So they took that into consideration, of course. So if there's a proc there or not, it's going to be handled. So let me just play with that real quick. So we'll just say hash.new. So I don't remember. Is it just why am I looking there? Default to new cat. Okay, yeah. Okay, so hash.new cat. So A then returns cat. And then if we have a block, let's call it I. So I think the block style, yeah, so the first argument in the block is the hash itself, and then k is the key. Okay, so we'll use that syntax. So hash key equals cat key. And if we say I a cat a. All right, so then if we require our indifferent access, I think I have to go over here to find that. And we say h dot, I don't even remember the name, with indifferent access. Okay. So if we do that, and then we access a cat, well, we didn't change anything, so b equals dog. And there we go. Then if we have our I, and let's just say I b equals dog b. Whoops. There we go. Okay, so that works quite as expected. So let's go on to keys. Got a lot more going on here. So let's just look at a couple and maybe end it there. So transform keys returns a new hash with all keys converted using the block operation. So transform keys key.2s.upcase. Okay. So it is going to convert the keys in a certain way. So if you want to, let's just go with our h. You say h.transform keys. Did I get that right? Yeah. x.2s. And there it is. And is it inline? No, it is not. But of course, they have a bang version of the method. So I wonder why this one, why they don't do the dupe style. Return enum for transform keys unless block given. What is enum for? It may not even be implemented in here now that I think about it. One of two. Nope. That could be a baked in method. Don't see it. Oh, there it is. Ah, yeah. Similar to kernel to enum, except it returns a lazy enumerator. This makes it easy to define enumerable methods that will naturally remain lazy if called from a lazy enumerator. For example, continuing from the example in kernel to enum. Yeah, okay. So it just returns an enumerator. Where were we? Keys. So enum 4. Enum 4 transform keys. So method each. What is that? What is that method doing? This makes it easy. Okay. Oh, I got it. Since it's a lazy enumerator, this is the method that's going to be called on the enumerator that's returned, because since this is only if there's no block given. What that does is if I say h.transform keys, that's going to be a numerator. Okay. That way I can call it one after another, and it knows the enumerator knows that it wants to call transform keys. All right. And then just result equals self.class.new. Each key do key, result yield key equals self key ln result. Okay, so it's constructing a new hash, and if this doesn't happen to be hash but rather a subclass, then it's going to instantiate the subclass. That's a nice little convention there. Each key do key. Okay, so it's enumerating over each key here, and then the new one is going to be replaced. Okay, so that now it makes a little more sense why these are not just different implementations of themselves. This can just do a little simple implementation, whereas this one has to actually delete the key since it's modifying the existing hash. So, all right. Well, let's look at one more method. So stringify keys returns a new hash with all keys converted to strings. Hash equals name, Rob, age 28. Hash.stringify keys. And it just transforms the keys. Cool. So it just uses that method that was created right here, and just calls it with a block that converts it to a string. Nice and simple. Well, I think that's a good stopping point for us for now. So maybe next week we can continue on and see what else hash has in store, or maybe we'll dive in somewhere else. But so please comment if you saw any mistakes, and if you have any suggestions, go ahead and leave a comment as well. And like this video if you liked it, and if you really liked it, please go ahead and subscribe, and I will see you next time. Thanks. Bye.